The National Electrical Code, or NEC, does not specify a required distance between air conditioning vents and smoke detectors. However, it is generally recommended to keep smoke detectors away from air vents to prevent drafts from interfering with their operation. Consult local building codes and the smoke detector manufacturer's instructions for specific recommendations. For clearance in front of disconnects, the NEC requires 3 feet or 914 millimeters of clear working space in front of electrical equipment such as disconnects. This space must be clear of obstructions and provide adequate room for electricians to safely operate and maintain the equipment. Regarding which type of wire should have inhibitor at all terminations, it is aluminum conductors that require an oxide inhibitor. However, of the choices you provided, 12/2 Romex does not need an inhibitor. The 8/3 SEU and 2/0 SER aluminum cables do require the use of an approved antioxidant compound at all terminations. This is because aluminum forms an oxide layer when exposed to air, which can increase resistance and lead to overheating. The inhibitor helps to prevent the formation of this oxide layer. For breaker size, for wire sizes, a 2/0 CR aluminum conductor is typically rated for 150 amps. A 4/0 SER aluminum conductor is typically rated for 250 amps. Always consult the NEC tables for the ampacity of conductors and the appropriate overcurrent protection. When installing ground rods, the minimum spacing required between them is 6 feet or 1.83 meters. This spacing helps to ensure that the ground rods are effective in providing a lower impedance path to ground for fault currents. For Romex support requirements, the NEC requires that Romex, or non-metallic sheath cable, be supported within 12 inches, or 305 millimeters, of a box or fitting and every 4.5 feet, or 1.37 meters, in between supports. This helps to prevent the cable from sagging or becoming damaged. It is essential to always consult the most recent edition of the NEC and any applicable local codes for specific requirements and regulations. Electrical work should only be performed by qualified and licensed electricians. The ampacity of a conductor, which is the current in amps it can carry safely, depends on several factors. Firstly, the conductor's material, whether it is copper or aluminum, is important. Copper generally has a higher ampacity than aluminum for the same size. Secondly, the size of the conductor, usually expressed in American wire gauge or AWG, affects ampacity. Larger conductors have a lower resistance and can carry more current. Thirdly, the insulation type of the conductor plays a role. Different insulation materials have different temperature ratings. The higher the temperature rating, the more current the conductor can carry safely. Fourthly, the installation method influences ampacity. Conductors installed in free air can dissipate heat more effectively than conductors installed in conduit or buried underground. Fifthly, the ambient temperature affects ampacity. Higher ambient temperatures reduce the conductor's ability to dissipate heat, lowering its ampacity. The NEC provides tables that list the ampacities of different conductors based on these factors. For example, NEC Table 310.16 lists the ampacities of insulated conductors rated up to 600 volts, based on their size, insulation type, and installation method. It is crucial to consult these tables to ensure that conductors are not overloaded, which could lead to overheating, insulation damage, and fire hazards. When determining the appropriate breaker size for a given conductor, it is important to consider the conductor's ampacity and the type of load it will be serving. The NEC generally requires that the breaker size not exceed the conductor's ampacity. However, there are some exceptions to this rule, such as for motor circuits, where the breaker size may need to be larger to accommodate the motor's inrush current. It is also important to consider the type of load being served. For example, a circuit serving lighting or general-purpose receptacles may be protected by a breaker sized at 15 amps or 20 amps, depending on the size of the conductors and the load requirements. A circuit serving a large appliance, such as an air conditioner or electric range, may require a larger breaker size to handle the appliance's higher current draw. When working with aluminum conductors, it is essential to use connectors and terminations that are specifically designed for aluminum. Aluminum is a softer metal than copper and has a higher coefficient of thermal expansion. This means that aluminum conductors can expand and contract more than copper conductors when subjected to temperature changes. If aluminum conductors are not properly terminated, this expansion and contraction can lead to loose connections, which can cause overheating and fire hazards. Aluminum connectors and terminations are typically made of aluminum alloy and are designed to provide a secure and reliable connection that can withstand the effects of thermal expansion and contraction. They also often include a corrosion inhibitor to prevent the formation of aluminum oxide, which can increase resistance and lead to overheating. When installing ground rods, it is important to ensure that they are driven deep enough into the ground to make good contact with the earth. The NEC requires that ground rods be at least 8 feet long and be driven into the ground so that at least 8 feet of the rod is in contact with the soil. In some cases, it may be necessary to drive the ground rods deeper to reach moist soil, which has a lower resistance than dry soil. It is also important to ensure that the ground rods are properly bonded together into the grounding electrode conductor. This helps to create a low impedance path to ground for fault currents. The grounding electrode conductor should be sized according to NEC Table 250.66, based on the size of the service entrance conductors. When installing Romex, it is important to follow the NEC requirements for support and protection. Romex should be supported within 12 inches of a box or fitting and every 4.5 feet in between supports. This helps to prevent the cable from sagging or becoming damaged. Romex should also be protected from physical damage. It should not be installed in locations where it is subject to abrasion, impact, or other forms of damage. In some cases, it may be necessary to install Romex in conduit or other protective raceways to protect it from damage. When running Romex through holes in studs or joists, the hole should be drilled in the center of the framing member to prevent the cable from being damaged by nails or screws. The NEC also requires that Romex be protected from contact with sharp edges. When running Romex through metal framing members, the edges of the hole should be debbered or covered with bushings to prevent the cable from being cut or damaged. When selecting wiring for a specific application, it's crucial to consider the voltage drop. Voltage drop refers to the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction, lights to dim, and motors to run inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. To minimize voltage drop, use larger conductors or shorten the length of the circuit. The NEC provides formulas and tables for calculating voltage drop based on conductor size, length, and current. It's essential to perform these calculations during the design phase to ensure that the wiring is adequate for the intended load. When installing electrical boxes, ensure they are properly sized to accommodate the number of conductors and devices they will contain. The NEC specifies fill requirements for electrical boxes to prevent overcrowding and ensure safe connections. Overcrowded boxes can lead to overheating, short circuits, and difficulty in making proper connections. The NEC provides tables that list the maximum number of conductors allowed in boxes of various sizes based on conductor size and box type. It's essential to consult these tables and select boxes that are large enough to accommodate the wiring without exceeding the fill limits. When making wire connections, use appropriate wire connectors and ensure they are properly tightened. Loose connections can cause overheating, arcing, and fire hazards. The NEC requires that wire connectors be listed and labeled for the specific application. Use connectors that are designed for the type and size of conductors being joined. When tightening wire connectors, follow the manufacturer's instructions and use a torque wrench if required. Over-tightening can damage the conductors or connectors, while under-tightening can result in a loose connection. Regularly inspect electrical systems for signs of wear, damage, or overheating. Early detection of problems can prevent more serious issues and ensure the safety of the electrical system. Look for signs of discoloration, melting, or burning on wires, connectors, and devices. Check for loose connections, frayed insulation, and damaged equipment. If you notice any problems, have them repaired by a qualified electrician immediately. Regularly test ground fault circuit interrupters, or GFCIs, to ensure they are functioning properly. GFCIs are designed to protect against electric shock by detecting ground faults and interrupting the circuit. They are commonly installed in bathrooms, kitchens, and other areas where water is present. The NEC requires that GFCIs be tested monthly to ensure they are working correctly. To test a GFCI, press the test button on the device. The GFCI should trip and interrupt the circuit. If the GFCI does not trip, it should be replaced immediately. When working on electrical systems, always follow lockout/tagout procedures to ensure that the power is turned off and cannot be accidentally turned back on. Lockout/tagout procedures involve disconnecting the power source, locking the disconnect switch in the off position, and attaching a tag to the disconnect switch indicating that the circuit is being worked on. This prevents anyone from accidentally turning the power back on while someone is working on the electrical system. Only qualified and authorized personnel should perform lockout/tagout procedures. When working on electrical systems, wear appropriate personal protective equipment, or PPE, to protect yourself from electric shock and other hazards. PPE may include insulated gloves, safety glasses, and arc-rated clothing. Insulated gloves protect against electric shock by providing a barrier between your hands and energized conductors. Safety glasses protect your eyes from flying debris and arc flash. Arc-rated clothing protects against burns from arc flash. The type of PPE required will depend on the specific task being performed and the voltage level of the electrical system. The NEC provides guidelines for selecting appropriate PPE for electrical work. When installing wiring in hazardous locations, such as areas where flammable gases or vapors are present, use explosion-proof equipment and wiring methods. Explosion-proof equipment is designed to contain any explosion that may occur within the equipment, preventing it from igniting the surrounding atmosphere. Wiring methods for hazardous locations include rigid metal conduit, which provides a robust and sealed pathway for the wiring. The NEC provides detailed requirements for installing electrical equipment and wiring in hazardous locations. These requirements are designed to minimize the risk of fire and explosion. When installing electrical equipment outdoors, use weatherproof enclosures and wiring methods to protect against moisture and corrosion. Weatherproof enclosures are designed to prevent water from entering the enclosure and damaging the equipment. Wiring methods for outdoor applications include underground feeder cable, which is designed to be buried directly in the ground, and rigid metal conduit, which provides a durable and weatherproof pathway for the wiring. The NEC provides requirements for installing electrical equipment and wiring outdoors. These requirements are designed to ensure the safety and reliability of the electrical system in outdoor environments. When installing electrical equipment near swimming pools or other bodies of water, follow the NEC requirements for bonding and grounding to prevent electric shock hazards. Bonding involves connecting all metal parts of the electrical system together to create a low impedance path to ground. Grounding involves connecting the electrical system to the earth to provide a path for fault currents. The NEC provides detailed requirements for bonding and grounding electrical equipment near swimming pools and other bodies of water. These requirements are designed to minimize the risk of electric shock. Regularly inspect and maintain electrical systems to ensure they are in good working order. Proper maintenance can prevent problems from developing and extend the life of the electrical system. Maintenance tasks may include tightening connections, cleaning equipment, and replacing worn or damaged parts. A qualified electrician should perform electrical system maintenance. When working with high-voltage electrical systems, take extra precautions to protect against electric shock. High-voltage electrical systems can be extremely dangerous and can cause serious injury or death. Only qualified and experienced electricians should work on high-voltage electrical systems. Before working on a high-voltage electrical system, ensure that the power is turned off and locked out. Use appropriate PPE, including insulated gloves, safety glasses, and arc-rated clothing. Maintain a safe distance from energized conductors and equipment. Never work alone on a high-voltage electrical system. Follow all safety procedures and regulations. Consider the environmental impact of electrical installations. Choose energy-efficient equipment and practices to reduce energy consumption and minimize pollution. Use sustainable materials and construction methods. Dispose of electrical waste properly to prevent environmental contamination. The NEC promotes sustainable electrical practices through its requirements for energy-efficient lighting, appliances, and other equipment. Stay up to date in the latest electrical codes and standards. The electrical industry is constantly evolving, with new technologies and regulations being introduced regularly. Staying informed about these changes is essential for ensuring the safety and compliance of electrical installations. Attend training courses, read industry publications, and consult with experts to stay up to date on the latest electrical codes and standards. Always prioritize safety when working with electricity. Electricity is a powerful and potentially dangerous force. Never take shortcuts or compromise safety for the sake of speed or convenience. Follow all safety procedures and regulations. If you are unsure about something, ask for help from a qualified electrician. Remember, safety is always the top priority.